Dear student, today I will do word conversion related to the carboxylic acid. At first, I will do the first question. An organic compound A having formula C7H6Cl2 on treatment with the sodium hydroxide solution gives another compound B which having formula C7H6O. B on oxidation gives an acid C having formula C7H6O2 which on treatment with a mixture of concentrated HNO3 and concentrated H2O4 gives a compound D, and the D compound having formula C7H5NO4. B on treatment with the concentrated NOH gives a compound E having formula C7H8O and C6H5CONA. Deduce the structure of A, B, C, D and E. Dear student, remember it is highly necessary write the structure of the compounds because your question is you deduce the structure of A, B, C, D and E. It is highly necessary to write the structure. Otherwise, mark will be reduced in the exam. For solving such type of conversion, it is highly necessary to the student. The student must read the questions repeatedly. It is highly necessary to read the question repeatedly and find out the key terms, key points. In this question, look at that. Here, concentrated NOH is given and a salt of carboxylic acid, that is your sodium benzoate, is given. At first, I will draw the structure of sodium benzoate. This is the structure of sodium benzoate. And it also given that E product is obtained and having formula that is C7H8O, and these two products can be obtained by the reaction of concentrated NOH with the B product. Here B is given. From this data it is clear that this is undergoes Canigerous reaction. As a result, we can easily think that this is said to be benzaldehyde. This is said to be benzaldehyde. When benzaldehyde undergoes reaction with the concentrated NOH, then benzyl alcohol, this is said to be benzyl alcohol. Benzyl alcohol is formed having formula C7H8O and sodium salt of benzoic acid is formed. This is said to be E. Now this is said to be B because B on treatment with the concentrated NOH gives a compound E. This is your E, and C6H5CONA. This is your sodium salt of benzoic acid. Now read the question again and find out the another term. B on oxidation gives an acid C. That means benzaldehyde undergoes oxidation, gives benzoic acid. This is the structure of benzoic acid. Here we can find out B on oxidation gives an acid C, having formula that is C7H6O2, and this is said to be C product. Next, again find out the key terms. Here is also a key term which on treatment with a mixture of concentrated HNO3 and concentrated H2SO4 gives a compound D. That means when C is subjected to reaction with the concentrated HNO3 and with the concentrated H2SO4, that is said to be nitration, then we can find out meta-nitrobenzoic acid because COH in benzoic acid is meta-directing in nature. That means we find out meta-nitrobenzoic acid, that is called considered as compound D and having formula C7H5NO4. Now calculate the number of carbon atom, number of oxygen atom, number of hydrogen atom, number of nitrogen atom. Then it is must equal to this formula. Look at the question again and find out the another points. An organic compound A on treatment with the NOH solution gives another compound B. That means B can be found by the help of reaction of aqueous NOH with the compound A. That means this is your compound A and formula is your C7H6Cl2. When C7H6Cl2 is subjected to reaction with the aqueous NOH, then benzaldehyde is formed. That means it is must be an aromatic compound which contains 2 chlorine atoms. So we can write this. This is our A. Now calculate the number of carbon atom, hydrogen atom and chlorine atom. It must be equal to this formula.
When it is subjected to reaction with the aqueous NaOH,
then what happens? This product is formed, but there are 2 OH atoms attached to 1 carbon atom. This is your unstable product, so it wants to stabilize like this and form the benzaldehyde. It is a intermediate product which is formed, but it is bound to write the equation like this. A react with the aqueous NOH gives B, because your question is given an organic compound A. This is your A. On treatment with the aqueous NOH solution gives another compound B. This is your B. B on oxidation gives an acid, that is your C, which having formula C7H6O2, which on treatment with the a mixture of concentrated HNO3 and concentrated H2SO4 gives a compound D. This is your D having formula C7H5NO4. B on treatment with the concentrated NOH gives a compound E. This is your E and C6H5CONL. This is the answer for the question number 1. Your A is your benzyl chloride, B is your benzaldehyde, C is your benzoic acid, D is your metanitrobenzoic acid, E is your benzyl alcohol. Next I will do the question number 2. An organic compound A on treatment with the ethyl alcohol gives a carboxylic acid B and compound C. Hydrolysis of C under acidified condition gives B and D. Oxidation of D with the KMnO4 also gives B. B on heating with the calcium hydroxide gives E. Having molecular formula C3H6O. E does not give tolerance test and does not reduce Fehling solution,
but respond to 2,4-DNPH.
From this question it is clear that E does not give tolerance reagent and does not reduce Fehling solution. That means E must be belongs to your ketone. And the formula of this ketone is your C3H6O. That means we can write that is your acetone. Acetone having formula C3H6O. So this is your E product. And we can write tolerance reagent, no reaction. Like that you can also react with the Fehling solution, no reaction. But remember 2,4-DNPH can be reacted with the acetone. We can write here 2,4-DNPH. 2,4-DNPH means 2,4-dinitrophenylhydrazine. When it is subjected to reaction, then it gives the structure of 2,4-DNPH is this. That is your phenylhydrazine 2,4-dinitro. Here one nitro group, here another nitro group. This is your said to be 2,4-dinitrophenylhydrazine. When it is subjected to reaction with the acetone, then there is a loss of water molecule and forms the product this. Here you can write a single bond N, and this is your H, and this is the product. Your NO2 group is present. Your NO2 group is present. The name of this product is your acetone 2,4-dinitrophenyl hydrazone. Now the E product is formed by the help of B product. B on heating with the calcium hydroxide gives E. That means you can write B here and give heating. This can be possible by the help of dry distillation, because your calcium hydroxide is given. This is your calcium hydroxide. So B must be an carboxylic acid. That means CH3COH, when subjected to reaction with the calcium hydroxide, then it gives a calcium salt of acetic acid. When calcium salt of acetic acid undergoes heating, it loses one molecule of calcium carbonate and gives you acetone. That means here the question is written B on heating with the calcium hydroxide gives E. That means it is bound to write your acetic acid CH3COH. This is your said to be B. Again, oxidation of D with the KMnO4 also give B. That means B can be formed by the help of oxidation of D. That means you can write this is your CH3CH2OH. CH3CH2OH. Oxidation of D with the KMnO4 also gives B. That means this is your D. Here another point is written, hydrolysis of C under acidified condition gives B and D. That means this product is formed, and also this product, this is your said to be D. These two products can be formed by the hydrolysis of C. Here we can write C. Hydrolysis of C under acidified condition gives B and D. That means the B product is your acetic acid and D product is your ethyl alcohol. That C product must be your ethyl ethanoate. This must be an ester. We know that when ester undergoes hydrolysis, then carboxylic acid and alcohol is formed. This can be done in acidified condition. That means H plus. This is a reversible reaction. This is your said to be C. You can write here also H2O. An organic compound A on treatment with the ethyl alcohol gives a carboxylic acid B and compound C. C can be formed by the hydrolysis of compound A. That means when A undergoes reaction with the ethyl alcohol, that is C2H5OH, then it gives C and another is also gives B. This means these two products. A must be your acetic anhydride CH3, C double bond O, C double bond O, bond CH3. When acetic anhydride is subjected to reaction with the C2H5OH, then it gives C and B. This is your said to be A. Again I will repeat, when acetic anhydride, that is your A product, treatment with ethyl alcohol gives a carboxylic acid B, this, and compound C, this. Hydrolysis of C, this undergoes hydrolysis. Hydrolysis of C under acidic condition. Hydrolysis of C under acidified condition gives B and also D. Oxidation of D, we can write your oxidation of D with the KMnO also give B on heating with the calcium hydroxide gives E, having molecular formula that is your C3H6O. E does not give tolerance reagent and also does not respond to the Fehling solution but respond to the 2,4-D-NPH. 2,4-D-NPH means dinitropenyl hydrazine. This is the answer for this question. Now I will do the question number 3. The question number 3 is your compound A having formula C6H12O2 on reduction with the lithium aluminum hydride yield two compound B and C. The compound B on oxidation gave D which on treatment with the aqueous alkali and subsequent heating furnished E. The compound D on further oxidation give acetic acid reduce the structure of A, B, C, D and E. It is highly necessary to draw the structure of A, B, C, D and E. Here in this question, here acetic acid is given. That means you can write first acetic acid. This acetic acid can be found by the oxidation of compound D. That means we can write this is your acetaldehyde, and this acetaldehyde is considered as a D product. This acetaldehyde, that means D which on treatment with the aqueous alkali, that means your aqueous alkali means it is undergoes your aldo condensation reaction gives beta hydroxy compound. This compound which on heating gives E means you can write CH3 bond CH double bond CH CHO. This is your E product. Next compound A on reduction with lithium aluminum hydride yield two compound B and C. The compound B on oxidation gave D, that means this is your ethyl alcohol CH3CH2OH. Ethyl alcohol undergoes oxidation gives acetaldehyde. This undergoes oxidation, that means D product undergoes oxidation gives acetic acid. The compound B product and C product is prepared by the reduction of compound A. That means we can write here CH3 bond C double bond O CH2 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 CH3. That is said to be butyl ethanol when it is subjected to reduction by the help of lithium aluminum hydride. Then B product is formed with another product, that is your C product is formed. The C product is your CH3 CH2 CH2 CH2OH. This is your said to be butanol. It is your said to be C product. Again I will repeat, this is your A product having formula C6H12O2 which on reduction with the lithium aluminum hydride give compound B and C. C is your butanol, B is your ethanol. B on oxidation gives C, D on further oxidation gives your acetic acid. This is your said to be acetic acid. D on reaction with aqueous alkali gives
and beta hydroxy product
which on heating gives product E. That is your alpha beta unsaturated product. This is the answer for this question number 3. Now I will do the question number 4. An organic compound A having formula C8H16O2 was hydrolyzed with dilute sulfuric acid to give a carboxylic acid B and an alcohol C. Oxidation of C with the chromic acid also produced B. On dehydration, C gives but1Ne. Write the equation for the reaction involved. Remember, for this problem, it is bound to write the equations. At first, I will write the structure of but1Ne, CH3, CH2, CH, double bond, that is the but1Ne. C on dehydration. C on dehydration gives but 1Ne. C on oxidation with chromic acid also produce, that is your B. B can be prepared by the help of compound A. The compound A having formula C8H16O2, which is subjected to hydrolysis H2O in the presence of dilute sulfuric acid, gives a carboxylic acid B. That means this is your carboxylic acid. Carboxylic acid. This must be your alcohol CH3, CH2, CH2. CH2OH. This must be your alcohol, that is your said to be butanol, and this must be your said to be butanoic acid, that is your CH3, CH2, CH2, COH. That is your said to be B. This is your said to be C. And again I will repeat the question. An organic compound A was hydrolyzed with dilute sulfuric acid to give a carboxylic acid B. This and an alcohol, that is your C. That means these two products also formed by the hydrolysis of A H2O H plus. This is your an alcohol, this is your an acid, and this can be formed by the hydrolysis of an ester. So we can write CH3 CH2 CH2 bond C double bond O bond CH2 CH2 CH2, that is your CH3. That is your said to be butyl butanoid. That compound is your said to be A, and it having formula C8H16O2. A compound on hydrolysis produce B and C. C on dehydration, you can take any dehydrating reagent. Suppose I want to take P2O5 as a dehydrating reagent, then it gives the but 1Ne. You aim to find out the A, B, C and write the equation. This is the answer for this question. Now I will solve the question number 5. An organic compound A on treatment with acetic acid in the presence of sulfuric acid produce an ester B. A on mild oxidation gives C. C with 50% KOH followed by acidification with dilute HCl generate A and D. D with PCl5 followed by reaction with ammonia gives E. E on dehydration produce hydrogen cyanide. This is your hydrogen cyanide HCl. This can be prepared by the help of dehydration of E. So the E product is your H bond C double bond O NH2. This is your amide product, undergoes dehydration,
Use HCN.
The E product is formed from D with the PCl5 followed by reaction with ammonia. That means here it is bound to write NH3, and this is your said to be acid chloride, and this acid chloride is formed from D. That means D is your formic acid. It is subjected to reaction with PCl5. This is your said to be D. Formic acid, when subjected to reaction with PCl5, then acid chloride is formed, which on reaction with NH3 gives a amide. And this is your said to be E. Again, look at that. C with 50% KOH followed by acidification with dilute HCl generate A and D. Here A and D is formed from C. This is your C product, and C is formed on mild oxidation of A. This is your mild oxidation. A on mild oxidation gives C. A on treatment with acetic acid, that means CA3COH, an organic compound A. This is your A on treatment with acetic acid in presence of sulfuric acid produce an ester B. When A and acetic acid undergoes a reaction in presence of sulfuric acid, suppose we write H plus, then ester is formed. This is your an ester, and that ester is considered as B product. A on mild oxidation gives C with the 50% KOH followed by acidification with the dilute HCl generate A and D. That means you can write C is your formaldehyde. Your C is your formaldehyde. When it is subjected to reaction with the 50% KOH, that is you think about the carnivorous reaction. Remember, when formaldehyde undergoes carnivorous reaction in the presence of concentrated KOH, then CA3OH
plus HCOK is formed.
Followed by acidification with dilute HCl, means this product is subjected to reaction, gives a formic acid, which is considered as the D product. Now the A product is your CH3OH methyl alcohol. This is your A product, which on mild oxidation gives a, that is your formaldehyde. This is your said to be C product. Then again I will repeat, C product under reaction with the 50% KOH gives A and D, followed by acidification with the dilute HCl. A, when treated with the acetic acid, it gives an ester, that is your B. So we can write here B is your CA3 bond C double bond O CH3, that is your methyl ethanoate, that is your B, and the E product is your this. This is the answer for this question. Now I will do the question number 6. An acid A react with the PCl3 to form compound B. A also react with the NOH to form a compound C. Both B and C react together and form acidic anhydride. What are A, B and C? Your acidic anhydride is given. The formula of acidic anhydride is your CA3CO twice O. This is your said to be acidic anhydride. This can be formed by the help of reaction of B and C. An acid A, when react with the PCl3 to form compound B, that is your PCl5. A react with the PCl5 gives B. A on react with the NOH gives a compound C. B and C when react with each other form acidic anhydride. That means this is your CA3COCl. If this is your CA3COCl, then this is your said to be CA3COH, and this is your said to be CH3CONA. That is your sodium acetate. You can take the byproduct, that is your NaCl, and form the acidic anhydride. This is your A. This is your said to be B. A also react with the NOH to form compound C. This is your C. B and C when react, then acidic anhydride is formed. This is the answer for this question. Now I will do the question number 7. An acid A react with the NH3 and form a compound B on eating gives a compound C. C on treatment with the Br2 and NaOH gives ethylamine. Write the name of A, B and C. For this question, it is bound to write the name of the product A, B and C. Otherwise, mark will be reduced. Here ethylamine is given, so at first write CH3, CH2, NH2. This is your ethylamine,
which produced from compound C.
C when subjected to reaction with the Br2 in the presence of NOH. That means it is your acid amide, so it is bound to write CH3, CH2, CO, NH2. This reaction is said to be Hofmann's bromamide reaction. This is a one type of degradation reaction. So this is your C, and the C product is formed from B. B on eating gives a compound C. That means B is your CH3, CH2, CO, O, NH4. The B product, this is your ammonium propionate. B product on eating gives C. Ammonium propionate is formed from A. That means your propanoic acid CH3, CH2, COH. This is said to be A. Then A is subjected to reaction with the NH3. Then ammonium propionate is formed. When ammonium propionate is subjected to heating, then propanamide is formed. And the C product, that is your propanamide, is subjected to reaction with Br2 in the presence of NOH. Ethylamine is formed. It is bound to write the name of the product, otherwise mark will be reduced. This is your said to be propanoic acid, and this is your said to be ammonium salt of propanoic acid. This is your said to be propanamide. It is bound to write the name of A, B and C. This is the answer for this question. Now I will do the question number 8. A colorless, pungent smelling liquid having chemical equivalent 46, strongly acidic to litmus. This is readily oxidized by KMnO4 but reduce mercury chloride to mercurous chloride. Heating the original substance with excess of sulfuric acid produce water and carbon monoxide. Give the structural formula of the compound. Suppose the compound is your A. Suppose A is your colorless, pungent smelling liquid having chemical equivalent. Equivalent mass is your 46. That is your also colorless. Next is your pungent smelling liquid. This is the readily oxidized. A that quickly oxidized by KMnO4 but reduces mercury chloride. That means A react with the mercury chloride HgCl2 to mercurous chloride, that is your HgCl. Heating the original substance, that means A is subjected to heating with excess sulfuric acid produces water, that is your H2O plus
carbon monoxide.
This type of characteristics is generally shown by formic acid HCOH. When formic acid reacted with the mercurous chloride and HCl is formed, and another also byproduct, that is your carbon dioxide is formed. When formic acid is subjected to heating with the excess sulfuric acid, then water and carbon monoxide is formed. The equivalent mass of formic acid is also 46, because the molecular mass of formic acid is 46 and its basicity is 1, so we divide by 1, that is 46. That is the equivalent mass. Equivalent mass is equal to 46 by 1 is your 46. So this is your formic acid. So we can write the structural formula of the compound is your H bond C double bond O bond OH. That is your said to be formic acid. This is the answer for the question number 8. This is all about your word conversion for carboxylic acid.